Seems like every other outage we have is fuse cutouts. Refuse cutout, broken fuse cutout. What are fuse cutouts? And so we have some photos here, and I didn't take any of these, by the way. So if we look up at the top left photo, there's one installed, and there's a wire coming off the top, and I've got one here I'm going to show in just a second, but I just kind of want to do a little prep work. There's a wire that comes off the top, and then there's a wire that comes off the bottom. And if you look at the center photo, that device right above that lineman's head, that's the fuse cutout, and there's a wire dangling down right in front of him, and it looks like it's got a little, something attached to it. So that is the wire to the fuse cutout, and it's detached. It's removed from the actual conductor that's giving power to it, and then you can see another wire coming off, and it goes to the transformer. And so, fuse cutout. Let me pull out the display model here. And I'll be drawing on Todd and a few others to walk through this. But the very first thing we see is there's a bracket here, a mounting bracket, and it looks bent. And it is. It's fabricated that way so that when you see these things installed, they're always hanging off at about a 20-degree angle. Todd, why is that?
Well, that way when your door opens and closes, if it's hanging at an angle, when it faults, it'll fall open. If it's hanging vertically, it may not, if this was level, it may not fall open. And the other part is when the linemen use their long sticks, they reach in here and they can pull it out just like that, and then they can put it back in. If this is at a different angle, this doesn't come out as easy. So it's designed for it to fall open, and then also for the lineman to pull it out with the long stick. All they do is take that little finger on the stick and do that right there with it, and then they grab down here and close it in. And so if you're out in the field, this is the way they are when they're in and energized. They're open. If the fuse blows, this door will drop down, and this door will be hanging down. And that's how the guys know that cutout is open.
Let's get power through this thing. So that wire from the photo is coming from here. Is that right? So we have a conductor, we call them, but it's a wire. It's a bare wire that goes up to our distribution line. And what typically is that voltage?
Our system mostly is 14.4.
So 14,400 volts.
14,400 volts.
On this side of the device, it comes in here, and of course, it would want to go down here and then to ground here, but it can't go down there. The electricity can't flow there, right? Why?
Because this is an insulator, and these skirts help insulate it. And the main purpose behind the skirts is so water can't track straight down the body of it. Because if it can go straight down, then it can create a path to ground eventually. So the skirt makes it go off and drip, and so it can't form that track.
So water on top will drip off. We can have dust or dirt accumulate on these.
Yes.
And then that would cause a short, but the underside would typically stay dry, and this part would stay dry, and so that insulates electricity from being able to go through this ground.
That's correct.
All right. And then so it goes through here into the fuse, or actually into the door through the fuse, comes out, and then this wire goes to where?
To whatever device you're powering. It could be a transformer, could be a line fuse, or it could be an underground riser. So you got basically those three: underground riser, transformer, or line fuse is what these are going to power. And so on the top, the lead coming out of the top will hook up to a hot line clamp, and that's a clamp that the guys can use a shotgun to reach up there with a grab ball. It's got a hook that reaches in there, and you can suck it down. And then you can spin it, and it opens it up, and you can put it on and spin it and then tighten it up. And That way they can lift it off and work on this de-energized without having to actually go up and put their hands on it. And then the bottom one comes down and goes to the device, whatever device you're powering up at the time.
So let's have Dirk out. He's patrolling the line, and we have an outage. And so, Dirk, what are you doing?
A lot of times looking for that open cutout when that door's open.
So you're looking for this door to be open?
Yep.
You want to give it a pull? So that's what you're looking for. 2 o'clock in the morning.
Yep.
Blowing snow.
That helps out. When the fuse is open, and then sometimes the door will be closed, and this little rope, this little rope fuse, if this insulator's failed, you'll see this little rope fuse hanging down out of there, and we call it like a rat tail. And so the door will be shut, but you'll see this little fuse hanging down. And a lot of times that means that porcelain cutouts has failed and it's shifted, and there's weight from that porcelain holding that fuse in place. And so sometimes power will track across that door if it's really dirty and everything.
Yeah.
And you'll have some weird stuff going on. But usually the cutout will be open. You'll know it's open. That can become an open point. You can take a clearance on that if there's something on the line you're gonna have to get your hands on. There's wire down or whatever. Call hydro, get a clearance, and then make repairs.
All right, let's pull it open again. And so that's what it looks like. And then, Todd, how would they take it off?
Use a stick, and it's got a little finger, kind of like this. It sits like this, and you stick it in here, and you pull it off. Now these sticks we got them, what, 50 foot long now?
Yeah.
We have 50 foot long sticks. So imagine taking a fiberglass fishing pole, if you ever used a cane pole for fishing, have one 50 feet long going straight up in the air. This door weighs about a pound and a half. And so you're running that up there. Sometimes the wind's blowing. It's a lot of fun. Some guys are really good at it, and you got a little tiny hole here, not very big, and you got to stick that little finger in that hole and to get it out and then put it back. Going back is not as bad, but then you got to line it up and slide it in there. Some guys are really good at it. If you do it after a while, a long time, you get really good at it. But if you haven't done it in a while, or a new person, yeah, it can be interesting.
All right, so inside here is a fuse.
Yes.
And can we pop that open?
Well, we got something to break this with.
Yeah. Do those come in different sizes?
Yeah, they sure do.
Nice.
We've got them from very, very little fuses to solid doors, basically.
So what does that mean, a solid door?
A solid door is just that. Would actually have no fuse here. It would just be, this would be all metal. And so they conduct up to 300 amps. And
That's Bob Ravenstown.
You waited the whole time to say that?
I'm not refusing it. I'm just, it's an inspection. I can do inspection. So this little device is the fuse. The actual fuse is inside this cardboard. So you don't see it, and when there's too much amperage for the fuse size, they're all sized differently, and it says right here what this one is. I don't know if my old eyes can read it.
The line crews have various sizes on their trucks ready to go.
Yes. They generally carry from 0.33 fuse all the way up to 100 amp is usually what's on the trucks. So the smaller the fuse is for little transformers. The bigger fuses are for line fuses or substation bypasses, things like that. So we do have up to 200 amp fuses in our system. Those are usually substation bypass fuses for reclosers. Yeah, this is the fuse. So when there's too much current going through there, that's a silver solder type metal in there, and so it just melts out. and then there'll be usually an explosion with these, and so it blows this bottom part out. You know, Dirk was talking about the tail hanging out, so this will come apart, and part of this will be hanging down on the bottom here. You'll see it hanging out of the cutout, and so then the guys take it apart, put a new one of these in, and you put it all back together, and then close the door, and then you got power again. After they've figured out what caused the fault, what made this fuse blow, they have to find that out first. Then they can refuse it, and after they've made repairs.
So, how many, if one of these blows, how many members are gonna lose power?
It depends on what it's feeding.
Okay?
You could have one person out on one transformer, or you could have 1,000 people out with a line fuse.
1,000 people out one of these blows, and so, or one person. And so the line crew, when they go up and they see it's open, Dirk sees it's hanging open, Dustin sees it's hanging open, he's gotta figure out why open. So what's he gonna do?
You gotta patrol the lines.
He's gonna patrol the line. So, maybe unloading the track rig and going out, or maybe walking, or maybe just driving along, shining a light. Okay, very good. Let's talk about